Hey everyone, this is Mike, and today we're going to take a floor plan that lives in a CAD file, and we're going to transform that within a Jupyter notebook into a format that Tableau can consume. All right, let's hop into that notebook. So here we are in our Python Google Colab notebook. Our notebook's going to start by reading in our DXF file into a GeoPandas geodata frame. After that, we're going to split the geodata frame based on geometry type into a few different component geodata frames. Then this is the fun step. We're going to establish control points. So you can think of control points as a mapping of the XY coordinates in our floor plan schematic and actual latitude and longitude in the real world. Then we're going to apply a linear transformation based on those control points to georeference our geodata frames, or in other words, convert that local XY coordinate into actual latitude and longitude. And then lastly, we're going to output our geodata frames into a spatial format that can then be consumed in Tableau. All right, I got a head start and I already installed GeoPandas into our Colab environment. And I also uploaded our CAD file. Once the CAD file is uploaded, I will go ahead and build our geodata frame. And let me scroll up for just a second. I do want to note I am using a DXF file for the CAD file. If your CAD file comes in DWG, which is like the AutoCAD proprietary format, I personally struggled with working in Python with DWGs using like free open libraries. So I made sure to either convert it or to just get a DXF file because those were way easier to work with using free Python libraries. So once our geodata frame has been built, and this cannot be easier, GeoPandas just has a read file which accepts CAD files, specifically DXF. And now we can preview what this looks like. So we have our layer in our CAD file, and then we have our geometries and our text. So the text is going to be empty for some rows, but we'll see that for the elements that we want, we will have text, and we can also plot this. So this is a little bit busy and ugly, and let's see what happens once we kind of see what types of geometries we have. So we have line strings, multi-line strings, geometry, collection, and points. And let's do the step where we parse out our geodata frames by geometry type and then preview them individually. All right. So our first one, this is probably our lines. Second one, I think this is our multi-line. This is very funny. Didn't know that our CAD file included like these I think they're chairs, little models of chairs. And then our fourth one is our points. So we just want the first and the fourth. So let's actually just create a line string geodata frame and a point geodata frame. And now we're going to do the control points. So I'm going to hop out of the Google Colab notebook and I'm going to visualize just the non-georeferenced geodata frame in Tableau like as a CSV file. And then I'm going to be bouncing back and forth between Tableau and Google Maps, and I'm going to record the control points. So I will also make kind of a note or caveat that we're going to be using latitude and longitude. Those are not linear or planar, meaning it's not like a XY plane. It's actually longitude and latitude are representing angles. But when it comes to a very small area of interest, we can totally cheat and treat them as linear, and we'll see in a second that the results we get are totally acceptable, at least like by my standards. But if you're building this is like a much larger CAD file over a much larger area, you would probably want to use a planar coordinate system as opposed to like UTM, as opposed to like at angles. Okay, this is a sped up video of me capturing some control points. I end up capturing 5 control points in total, and the more you capture, the better your mapping is going to ultimately be. And the more accurate you capture them, the more accurate your mapping is going to be as well. There are GIS programs that do this, but I figured Google Maps will get the job done. Let's bring in our control point mappings as a Python dictionary and then use that dictionary to build a data frame. So now we're going to do 2 linear regressions using these control points. The first one will map our local x to latitude, and the second one will map our local y to longitude. We'll see in a second later that you might be thinking, wait, isn't latitude supposed to be more of a y and longitude more of an x? We'll do a little flip-flop at the end, but basically like my CAD file wasn't north oriented, or in other words, up in the CAD file, or a high y value did not correspond to north. And the CAD file needed to be kind of rotated. So again, we're going to correlate our control points. So we'll go ahead and build our regression model and see how good the model is. So right here, you can see this is, when I say regression model, it sounds very complicated, but this is just y equals mx plus b, kind of like math from high school. And we can see our R squared values are very close to 1, which means the mapping is fairly linear. So very, very linear. Again, like if this was over a much larger area, I would not want to do latitude and longitude necessarily. I'd want to do something. I would want to use more planar coordinate system. All right, so now that we have those linear regressions, we can go ahead and apply them. And we can preview our results. All right, so these axes look weird because it's like negative 7.70 e to the first, and then, yeah, so that like the labels are weird, but these look like latitude and longitude. And we're gonna swap out our x and y because again, our CAD file wasn't north oriented. We could have kind of fixed our CAD file or made it north oriented and then did our control points. That probably would have been a bit simpler, but this will go ahead and work. And we'll plot that again. And this actually is now in the shape of what the building looks like. So we will output this to GeoJSON, and we will do the same thing for our line strings. It's going to take a bit longer because the line strings are a bigger file, or bigger, there's more data in the line strings. And we'll do the same thing where we will output our line string geodata frame as a GeoJSON. And by the way, to actually download them, we will want to go into our Google Colab kind of file space and download these from here. Okay, final step. Let's bring in our 2 GeoJSON files into Tableau and make sure everything looks okay. All right. Overlay some streets. And that's exactly where the building is. So we did a pretty good job with the control points. Now let's bring in our line string. And we're not going to join or blend or relate the data. We're just going to overlay the geometries as 2 separate marks layers. Awesome. Maybe change the color of the points. And there you have it. We took our CAD file, we extracted the geometries and the relevant information, we georeferenced that and built a spatial file that you can bring into Tableau. Thank you for listening. Definitely check out the Substack post where I'll go into more detail and also give a link to the Jupyter Notebook. All right, see you next time.